This video on Lesson 7-4 is being made to help those students review some of the lesson that was done on Monday and Tuesday of this week, as well as if you were absent and you needed to be able to catch up. So Lesson 7-4 was done over 2 days, Monday and Tuesday, and on Thursday when we come back together as a class, we'll get a chance to spend some time at the whiteboards working and practicing. So our essential question for this lesson is, how can you solve a polynomial equation? And our learning objectives for this lesson is, students will be able to use the zero product property and then factor polynomials using the GCF. In addition to these primary learning objectives, we're also going to take a look at solving real-life problems. So on the first page of this lesson, you're going to see a graphic organizer. So this is deliberately left blank in order for you to be able to jot down words as we go through the lesson and define them if you're unsure or unclear. So turning the page over on page number 12, the very first thing that we're going to be learning about is using the zero product property. Well, in order to be able to do that, there's some background knowledge that I need to activate that you learned way back in middle school and even in elementary school. So the very first box says, what is a factor? And we know a factor to be numbers that we multiply together to get another number. So here's an example of a factor. 3 times 4 equals 12. 3 and 4 are both factors because we multiply them together to get another number, and that number is 12. In algebra, we also use factors. And in algebra, factors can be expressions like x plus 3. And we can take x plus 3 and multiply that with another expression. So in algebra, this is what it looks like. We have x plus 3 being multiplied by x minus 1, and we get x squared plus 2x minus 3. That's the other number that we get, or other expression that we get. But what are the factors in this equation? The factors are x plus 3 and x minus 1. These are both factors. So make sure that you have that information down because it's important information because we're going to use that over and over again. The next box is, what is a product? Well, I'm hoping that you remember that a product is an answer to a multiplication problem. So up here, the product is 12. Okay, so let's move on. I'm going to give you some examples of standard form and what a factored form looks like. So a standard form, we learned about that in the last the first part of this chapter. And basically, we can write it in descending order. So I have x squared plus 2x. That is an expression or a binomial written in standard form. This is equal to, and I'm going to factor what this looks like, x times x plus 2. So again, I went from standard form to factored form. Notice the terminology of factored. So I've got two factors. I have x and x plus 2. And what happens when I multiply those two together? I get x squared plus 2x. Let's take a look at another example. X squared plus 5x minus 24. I've written that trinomial in standard form. Now I'm going to write them in a factored form. That is x minus 3 and x plus 8. So when I look at this, what are the two factors of x squared plus 5x minus 24? The factors are x minus 3 and x plus 8. So I just want to give you an example of what it looks like. This is where we're going. We're going to be learning how to factor going from standard to factored form. Okay, so let's take a look at the first concept. The first concept that we're learning about is called the zero product property. So basically, if I were to ask you, what is 3 times 0? Your answer would be 0. If I asked you what is 0 times 10, your response would be 0. Anytime I multiply a number by 0, I get 0. One of the factors is 0. Take a look here. 0 times 10 is 0. One of the factors is 0. So I'm going to use this property and I'm going to apply it in algebra. In algebra, we say that if the product of two real numbers is 0, then at least one number needs to be 0. That's what I just demonstrated right here. In algebra, if a and b are numbers, real numbers, and a times b equals 0, then either a can be 0 or b can be 0. Either one. So let's take a look in more detail what that looks like. So let's take a look here at this first example. We have an equation of 2x times the quantity of x minus 4, that's equal to 0. Well, what are the factors of this equation? The factors are 2x and x minus 4. Okay, so now let's go back, and it's asking us to solve. If I solve, then that means I need to get a value of x. Well, I have two values of x, and what else do I notice? I notice that when I multiply 2x times x minus 4, I get a quantity of 0. So remember, if I get an answer of 0, then one of these factors has got to be 0. So therefore, I can solve a polynomial equation by setting them both, each by itself, equal to 0. So this is what I mean by that. I'm going to take 2x, and I'm going to set that equal to 0, and I'm going to set that term of x minus 4 also equal to 0. And what I'm basically then doing is solving for the value of x. So in this case, x is equal to 0, or what else can x be? X could be equal to 4. So let's think about that for a minute. That means if I substitute 0 back into this equation, it should equal 0. And the same thing when I put 4 in. It should equal 0. Well, let's just demonstrate and do that. I'm going to put 0 in for x right here. Okay, and right here. I'm going to go 2 times 0 times 0 minus 4. That equals 0. Well, take a look, right? What's 2 times 0? I can even just go back here. What's 2 times 0? Well, 2 times 0 is 0. So that works, absolutely. And please remember that if this factor is 0, then the whole equation is 0. Because anything times 0 is going to be 0. I can do the same thing here for 4. If I substitute 4 in right here for x, because I found out that x is equal to 4, well, what's 4 minus 4? Well, 4 minus 4 is 0. And if I put it back up here is 0. And 0 times 2, well, that's equal to 0. So I'm able to solve and get a value of x by setting both factors equal to 0. In doing so, I am using what is known as the zero product property. Let's continue and do the next one. X minus 3 times x minus 9, and I'm saying it's equal to 0. So let's go ahead and put in the factors. What are they? X minus 3 and x minus 9. Well, according to my equation here, the whole equation is equal to 0. Therefore, I know one of these factors, either x minus 3 or x minus 9, must be equal to 0. So, I set it equal to 0, and I solve for x. So, x minus 3 is equal to 0, therefore x is equal to 3. Well, 3 minus 3 is 0, definitely. Well, that's how I get 0 as one factor. So now let's look at the other factor. X minus 9 is equal to 0. Therefore, x is equal to 9. Okay, so either one. Either x can be 3 or x can be 9. And they will both satisfy to make this equation equal to 0. Let's continue and do C and D, just for a couple of more examples. 3x and x minus 6. Again, what are the factors? 3x and x minus 6. I'm going to go ahead and set each one of those to 0. So 3x is equal to 0, therefore x is equal to 0. And x minus 6 is equal to 0, therefore x is equal to 6. Again, I've got either value of x will work to make one of these factors 0. And I do that again with D. As a way for you to practice, you should go in and do 1, 2, and 3. Okay? So now, that is setting them equal to 0 and solving. So now let's take a look at example 2. Well, how does this differ than what we did in example 1? Well, in example 1, it was a little bit more straightforward. I did not have two binomials. I had a monomial times a binomial. So take a look up here. Monomial times binomial. Now I'm being given two binomials. Well, I'm going to approach the problem in the exact same way. I'm going to set both factor equal to 0. And I'm able to do that because the entire equation is equal to 0. So I'm going to write 2x plus 7 is equal to 0 and 2x minus 7 is equal to 0. Solving for x, I'm going to apply all the algebra I learned in the first semester. So I know that x is equal to negative 7 over 2. Okay, that's one value of x. Or I need to figure out what the second value of x could be. So I'm going to get that 2x is equal to 7. Therefore, x is equal to 7 over 2. So either value will make one of these factors 0. Take a look at B. So I need to remind you that what does that square mean? That square means I can write it twice. So x minus 1 times x minus 1. And that's all equal to 0. So take a look. Well, I've got two factors that are the same. Therefore, I can set one of those equal to 0. Solve for x. X is equal to 1. And I know that that will work up there in that equation, making it 0. I'm going to go ahead and do C, just because now what are we given? We're given 3 factors. And each of the factors, they're all equal to 0. Therefore, I'm going to set each one of those factors, each one of them, I'm going to set equal to 0. And I'm going to solve for the value of x. So what do I get? I get that x is equal to negative 1. Or x can be equal to 3, or x can be equal to 2. Any one of those will work. So, in order for you to be able to go ahead and just practice, D, E, and F, and then 4, 5, and 6 should be done. I've actually, online in Canvas, sent everybody the entire packet of Chapter 7 notes that have been completed, so you could double check your work against what I've done. Okay, moving on. Now, I'm turning the page to page number 14. And now we're going to move on to the second part. So let's just go back and make sure, thinking about our learning objective. What was our learning objective? Students will be able to use the zero product property. I've just taken care of that. And we've worked through a couple of different examples, and you should go in and make sure you do all the monitoring practice as well as the additional examples to make sure that you understand how to do it. We're now going to move on to the second learning objective, which is factoring polynomials using the GCF. So, let's talk about the GCF. What does the GCF stand for? Well, the GCF stands for the greatest common factor. And we did some work prior to us starting this chapter on finding the GCF between numbers. So if I ask you, what is the GCF between 12 and 20? You were asked to make a factor list of 12 and a factor list of 20. And we did this on a homework assignment. So the factor list of 12 would be 1, 2, 3, 4, 6, and 12, right? Because I can multiply 1 and 12 together to get to 12, 2 and 6 together, and 3 and 4 together to get 12. Okay, and my factors of 20, again, I start with 1, and I know that 2 is a factor, I know that 4 is a factor, I know 5 is a factor, I know 10 is a factor, and I know 20 is a factor. So again, I know that these are all factors of each of those numbers, and now what I'm doing is I'm looking for the biggest number that they both share that's in common with both lists. And if I look at that, I see that that number is 4. So, what is the GCF and how do you determine it? Well, I just explained how to determine the GCF. So the greatest common factor is the biggest number that sits in both of the numbers, or the biggest factor that sits in the two numbers that you're being asked to factor out. Okay, so now we're going to take it and we're going to up the complexity a little bit by now being asked to find the greatest common monomial factor. So, we are no longer just dealing with numbers, we are dealing with monomials and binomials. So take a look. I've got this binomial. The binomial says 4x to the power of 4 plus 24x to the power of 3. And if I were to just look at that and say, okay, what's the greatest common factor? So what's the greatest number that sits between 4 and 24? You would be able to tell me that the GCF is 4. Most definitely. But I want to know what the greatest common monomial factor is. So what that means is I'm looking for more than just the number. So we can approach this a lot of different ways. I can ask you right now, and I'm going to actually work this out step by step. If I were to actually write this and expand it out, I would write 4 times x times x times x times x, right? That's 4 times x to the power of 4 plus. And if I know that my GCF is 4, I'm going to use 4 as the factor because it's one of the GCFs. So I'm going to go 4. And what do I multiply with 4 to get to 24, 6. So 4 times 6. And then I have x times x times x. So all I'm doing is I'm expanding it out. Okay, so now what I need to do is what's common to both? Well, definitely 4. Okay, I'm going to double underline that. What else do I see that's common? Well, I see a number of x's. I see an x here. Okay, here's an x. Oh, I see another x. Another x. Another x. And so now take a look. I've run out of x's on the right-hand side, but I still have one x here. So in other words, my GCF, or my greatest common factor monomial, my greatest common monomial factor is 4x to the power of 1, 2, 3, 3. Okay, so now, what do I need to do? Well, now what I need to do is I need to factor out the GCF of 4x to the power of 3. So what does that look like? It means I'm going to take each term and I'm going to, in a sense, divide it out. So if I divide it out, I'm going to put it over here, 4x to the power of 3. Okay, parentheses. I'm pulling it out of each term. So if I pull this out, what do I have left? X. Okay, plus. And if I pull it out again, I'm going to pull out a 4, and I'm going to pull out all 3 of those x's. What do I have left? 6. So what I've essentially done, if I were to show it a different way, is if I have 4x to the power of 4 plus 24x to the power of 3, I've divided, in a sense, pulled out 4x to the power of 3 from each term. So what am I left with? 4 divided by 4 is a giant 1. X to the power of 4 divided by x to the power of 3 is, I'm left with x to the power of 1. There it is right there. And 24 divided by 4 is 6. And x to the power of 3 divided by x to the power of 3, well, that's a giant 1. So I'm left with just 6. So I have 4x to the power of 3 times x plus 6. And to double check my work, I strongly encourage you to use the distributive property, because what should this all equal? This should equal 4x to the power of 4 plus 24x to the power of 3. So let's do that. Distribute means I've got 4x to the power of 4 plus distribute 24x to the power of 3. So I've worked example 3 out in extreme detail, and because I wanted to show what's actually going on. Okay, so let's do the same kind of detail with this second example. Okay, and I'm going to do it the exact same way. I am going to first look at the two numbers. Okay, and what is the GCF between 12 and 3? Well, I know the GCF between the two of them is definitely 3. So, now what I'm going to do is I'm going to rewrite each term using 3 as a factor. So, what do I got here? I have 3 times 4, and I'm going to go times x, times x, times x, plus. Now I'm going to do 3x squared, and I'm going to expand it. 3 times x times x. Okay, so now, what did I do the last time? I'm going to take, and I'm going to figure out what do I have common to both. Well, most definitely 3. There it is right there. And now I don't have any 4s, so now I'm going to look at the x's. I got x and x oh, I've got x and x. So what's my greatest common monomial factor? My greatest common, so GCMF is 3x squared, or 3x to the power of 2. So now I need to factor that out. So remember what I said. I'm going to pull it out from each binomial. Pulling it out means, in a sense, I'm going to divide everything by that to see what I have left over. So this is what I do. I'm going to pull it out in front of my parentheses. So I'm going to write 3x squared, parentheses. So now I've got to go in and I've got to figure out what's left. Well, I pulled this out and I pulled this out. So what do I have left? I have this and this. So I have 4x. Okay, so now wait a minute. I pulled the whole thing out. Well, remember what I said. It's like dividing everything by 3x squared. So what's 3x squared divided by 3x squared? 1. Okay, so plus 1. Okay, so 3x squared divided by 3x squared is 1. It's not 0, it's not x. It's the same number divided by, or the same expression divided by the same expression is 1. So what do I have? I have 3x squared times 4x plus 1. And go ahead and double check your work by using distribution. So I have 12x to the power of 3 plus 3x squared. And that's what all that's equal to. Okay, so now I've done 2 examples in detail. And now what I'm going to do is, in the monitoring progress, I'm actually going to do this one quickly by not the detail. But if you need to do it in a step-by-step fashion, then by all means do this. So let's take a look. Factor out the greatest monomial factor. I have 8y squared minus 24y. Well, what do I notice? I know that my common factor between 8 and 24 is 8. What else do I notice? I know that I've got y squared and y, and I know that y sits in y squared, so my greatest common factor is 8y, my monomial factor. So I'm going to go ahead and factor 8y out from each monomial right there. So this is what it looks like. 8y. So if I take 8y out from 8y squared, what do I have left? Simply y. And now I'm going to take 8y out of 24y, and what do I have left? Minus 3. And there we go. So I can double check my work by distributing. So I get 8y squared minus 24y. So I should always make sure I check my work to make sure I haven't made any mistakes. Okay, so that's monitoring progress in 3 examples, finding the greatest common monomial factor. There is lots of practice in the checking for understanding this week that you should do, and I'm going to go over that in just a minute. Let's go on and look at example 4. So now we need to solve equations by factoring. And one of the things I want you to remember is, remember back here in example 1 when we needed to solve a polynomial equation, and what did we have it equal to? We had it equal to 0. So in order for me to be able to solve, I need it to look like 2 factors, and I need it set equal to 0. And you're going to see a variety of examples in this next example 4 about solving equations by factoring. So let's take a look at this first example. This first example asks us to solve 2x squared plus 8x is equal to 0. So the first thing I do is I go, wait a minute, I'm looking for factors. Well, I've got monomial, monomial. In fact, this is a binomial, right? Got two terms, but it's set equal to 0, and I'm looking for factors. So remember, I'm looking for things, expressions that have got parentheses around them, and I don't see that. So what did I do? If you look up here, what did I do to these expressions? I factored out the greatest common monomial factor. And look what happened when I did this. I got 3x squared and I got 4x plus 1. In other words, I've got two factors. So let's go ahead and do the same thing here. So 2x squared plus 8x equals 0. Very first thing I'm going to do is I'm going to find the greatest common monomial factor. In other words, the greatest common monomial factor. So what is the greatest common monomial factor between 2x squared and 8x? Well, it is definitely 2x. So in other words, what I'm going to do is I'm going to take 2x out of 2x squared and 2x out of 8x. So I'm going to pull it in front. And what do I have left when I do that? I have x plus 4. And what is that equal to? It's equal to 0. Because that's what it says. It's equal to 0 up there. Therefore, it's equal to 0. Therefore, the minute I've got something equal to 0, I am doing the happy dance. The reason why I'm doing the happy dance is I know I can solve each factor and set it equal to 0. So let's go ahead and do that. So I know that 2x is equal to 0. And x plus 4 is equal to 0. And I'm going to continue to solve, and I find that x is equal to 0, or x can be equal to negative 4. And both solutions for x will work up here and make it equal to 0. Okay? So now what do we do? Well, we continue our work in B. So take a look. Okay, well now they're kind of throwing me off a little bit. I'm looking for 0. There is no 0. It says 6n squared is equal to 15n. Well, remember, guys, in algebra, I can move things around in order to satisfy certain requirements. So what can I do here? Well, let me show you. What happens if I take 15n away from this side? What's 15n minus 15n? Well, that's 0. And remember, in algebra, whatever I do to this side, I have to do to the left-hand side. I need to keep it balanced. So what happens if I subtract 15n from this side? What do I get? Let me show you. You're going to get 6n squared minus 15n is equal to 0. So now I got something equal to 0. I got something equal to 0, but I don't have two factors. But I'm going to notice something about 6n squared and 15n. They share a common factor. And what is that common factor? That common factor is it 6? No. What are the factors of 6? 3, 2, 6, 1. So I know the greatest common factor, or the factor that the greatest common monomial factor that sits in both of them is 3n. So 3n, I'm going to pull it out from each term. So that means I get 2n. And now I'm going to take 3n out of 15n, and what do I get? I get 5. Right? In other words, what I'm doing really is dividing. Dividing each term by 3n. Okay? And this is all equal to 0. So now look what I've got. I've got a factor. I've got another factor. And my equation is equal to 0. Therefore, I know that I could set each factor equal to 0. And there you go. Continue to solve. I know that n is equal to 0. And then over here, I've got to continue my math Please remember, I'm doing now, this is a two-step equation. I have 2n minus 5 is equal to 0. I'm going to move the 5 over, and then I'm going to divide both sides by 2, which therefore means n is equal to 5 over 2. So, this is n can be 0 or n can be 5 over 2. Okay? So, that's example 4. And you're going to see C and D on the next page. C is just like what we did in A. And look at D. D is just like what we did in example B. So I'm going to quickly do C and D to kind of walk you through. So again, I've got this equal to 0. I've got 4x squared and 12x. I'm looking for the greatest common monomial factor. So the biggest factor that sits in both 4x squared and 12x, and that is 4x. So what I'm going to do is I'm going to factor out, or I'm going to divide everything, 4x squared and 12x by 4x, or I'm going to pull out, any which way you say it. I'm all doing the same thing. So I'm going to factor out 4x from 4x squared, and what do I get left? I have x left. And what happens when I factor 4x out of 12x? I get 3. And all of that is equal to 0. So now I'm going to continue to solve, because I need to solve. So what do? I set each factor equal to 0. Continue to solve for x. And I get that x to be equal to 0, or x to be equal to -3. Same thing with D. You're going to notice that I have -10a squared is equal to 8a. So remember, in order for me to be able to solve, I need the right-hand side to be equal to 0. How do I do that? Well, I'm going to move this 8a. How do I move that 8a to make it 0? Well, I'm going to subtract 8a from the right-hand side. And please remember, whatever I do to the right-hand side, I have to do to the left-hand side. So I'm going to subtract 8a, draw my line. What do I have? I have -10a squared minus 8a, and that is equal to 0. So now, I need to ask myself, what's the greatest common monomial factor between the two of them? So in other words, I'm looking for the biggest term that sits in both -10a squared and -8a. Well, the greatest common monomial factor is 2, or -2a. You're probably going, why'd you take out the -2a? Well, both of these are negative, so I'm going to pull out the -2a. So in other words, what am I going to do again? I'm going to divide each term by -2a. In other words, I am going to be factoring it out. I'm going to be pulling it out of each expression. So I'm going to put -2a in front, my parentheses, and I'm going to take -10a squared and divide it by -2a, and what do I have left? I have 5, and what's left over? 5a. Now I'm going to take -2a and I'm going to divide it into -8a. Negative divided by negative is positive, so plus 4. And what does that equal to? It's equal to 0. So now I'm going to set each one of these factor is equal to 0. So I get negative 2a is equal to 0. And 5a plus 4 is equal to 0. A is equal to 0. Or, remember, I'm solving a two-step equation, so I'm going to subtract 4 from both sides, and I get 5a is equal to negative 4. Therefore, a is equal to negative 4 over 5. So I've got two values of a that'll make that equation equal 0. Okay, so you've got 3 more problems that you could do to practice to help you out. Now let's talk about the homework. So if you were absent Monday and Tuesday of this week, Monday I assigned the odd problems at the top, 1, 3, 5, 7, and 9. Okay? For Tuesday, I wanted you to do a lot more practice because this is brand new stuff, and this stuff, you just need to practice it over and over again. So, I wanted you to do 12, 13, 14. On the back side, 15, 16, 17, 18, okay? And then on this blue sheet, I wanted you to do at least 4 of them. This is all about solving, okay? And on the back side, factoring. So do as many of these as you can. The more you do, the better off you'll be because you'll just get tons of practice. Okay, now, there's one more little piece that I want to talk to you about, and that is on this yellow sheet here, we talked about a graph, and it asks you to find the x-coordinates of the points where the graph crosses the axis, the x-axis. So take a look. Here's my x-axis. Where did it cross the x-axis? Right there and right there. In that, question number 10. And in question number 11, here's my x-axis. It crossed right here and right here. Well, it's asking you to tell me approximately or tell me what the x-coordinates are. Well, I'm looking at this, and that's 4. That means that's 4, negative 4. So it looks like I'm counting by 2. So that's 2, 4, that's 6. So that could be 5. So x is equal to 5 there. And if I look over here and I go 2, 4, well, that's negative 5. Okay, so I got x is equal to negative 5 and x is equal to 5. But then what I wanted you to do is take a look at this equation. Y is equal to x minus 5, x plus 5. So I basically have taken x minus 5 and I've solved for 0. And I got x is equal to negative 5 and x is equal to 5. So basically all I wanted you to do is take a look at the equations and notice that if I were to actually solve for x and x, I would get negative 5 and 5. And basically when I have a parabola that crosses the x-axis, that is when y is equal to 0. And where y is equal to 0, I could set each factor equal to 0 and solve for x. If I look over here at number 11,
please disregard the...
When I look at number 11, you're going to see that I have x minus 2 and x plus 4. I'm looking for where the parabola crosses the x-axis. I know at that point y is equal to 0 in both instances. If that's the case, I can take x minus 2 and x plus 4 and set each of those equal to 0 because y is equal to 0 at that point in time. Y is equal to 0 at that point in time. Therefore, I know that x is equal to 2 and x is equal to negative 4. And I have basically found the x coordinates. So the piece that I want you to remember is, if you look back on page 12. The solutions of a polynomial equation are also called the roots. So please remember that the roots are when x is equal to a value and x is equal to a value. Remember, in all the things that we've been solving for, we've always had two x values. I've had x is equal to this or x is equal to that. You can get where you'll only have one x is equal to. But in all of these cases, y is always equal to 0. Okay? So, you've got lots of things to keep you busy. Tomorrow, during algebra class, during either first or third period, we're going to do a little bit of practice at the board. And then we're going to do this real-life example, modeling with mathematics. And then what we're going to do is we are going to go in and do the next lesson, which is lesson 7-5, and we're going to start to factor polynomials directly. Thank you, and I hope you have found this video useful.